Modeling is an important part of systems analysis and design. You saw many different models in Lesson 1 for the trade show system. Analysts build models to describe system requirements and use those models to communicate with users and designers. So by developing a model and reviewing it with a user, an analyst demonstrates an understanding of the user's requirement. If the user spots errors or omissions, they are incorporated into the model before it becomes the basis for subsequent design and implementation activities. So here are the reasons for modeling. So first, learning from the modeling process, reducing complexity by abstraction, remembering all the details, communicating with other development team members, communicating with a variety of users and stakeholders, and documenting what was done for future maintenance and enhancement. So, a model is a representation of some aspect of the system being built. There are dozens of different models that an analyst or designer might develop and use. So here are some of the examples of these models. You have event list, use case diagram, class diagram, sequence diagram, and a lot more. So smaller, simpler system projects will not need models showing every system detail, especially when the project team has experience with the type of system being built. So analysis and design models can be grouped into three generic types: textual, graphical, and mathematical models. So textual models, these are the text-based system models such as memos, reports, narratives, and lists. So the example here, so the event list and use case descriptions are two examples of textual models. The graphical models, these are system models that use pictures and other graphical elements to create a diagram. So such as this one, this use case, location diagram. So these are all example of graphical models. So graphical models make it easier to understand complex relationships that are difficult to follow when described as a list or narrative. Also, recall the old saying that a picture is worth 1,000 words. And mathematical models, these are the formula statistic algorithms. So these are system models that describes requirements numerically or mathematical expressions. So analysts often use mathematical models to represent functional requirements for scientific and engineering applications, and occasionally use them to describe business system requirements in areas such as accounting and inventory control. So many graphical models used in system development are drawn according to the notation specified by the Unified Modeling Language or UML. So in this figure, the use case diagram, class diagram, activity diagram, sequence diagram, communication diagram, and state machine diagram are UML graphical models. So UML is a standard set by model constructs and notations defined by the Object Management Group. It is a standards organization for system development. By using UML, Analysts and end users are able to depict and understand a variety of specific diagrams used in the system development project. So prior to UML, there was no standard. So diagrams could be confusing and they varied from company to company or from book to book. So in the next lessons, you will learn how to develop many of these analysis and design models. So the first diagram that we will cover in this lesson or in this section is the activity diagram. So through the process of building models, an analyst not only documents a business process or workflow, but he or she also will come to understand the workflow in more detail. So a workflow is a sequence of work steps or processing steps that completely handle one business transaction or customer request. So UML activity diagrams provide a simple technique to document business workflows. So one effective way to capture this information is by activity diagram. So an activity diagram is a UML diagram that describes user or system activities, the person who does each activities, and the sequential flow of these activities. So this figure shows the basic simple symbols used in an activity diagram. So the flattened ovals such as this one right here represent the individual activities in a workflow. So for example, review financials or prepare report. So these are the activities. Individual activities. So the connecting arrows represent the sequence of the activities. So the black circle denote the beginning and end of the workflow. The diamond is a decision point at which the flow of the process will either follow one path or another. Maybe could be yes or could be no, but not both. And then the heavy solid line is a synchronization bar, which either split the path into multiple concurrent paths or recombines or join concurrent paths.